Hi, I'm Ollie Hooper, a quantitative developer at QuantConnect, and this is Idea Streams, a weekly video series where we test an idea derived from current market trends by building a trading strategy on QuantConnect. In this week's Idea Streams, we're going to be looking at reducing the political risk in our portfolio by using an alternative dataset from Quiver Quantitative. So let's check out what this dataset is. Let's head over to their website, and we're going to be using their political beta dataset. So what this is the correlation between daily price changes and then the presidential candidate elections betting odds. At the moment, we're going to use a Dropbox CSV, but the team is working on integrating the Quiver Quantitative data into QuantConnect, so it will appear like any other custom data on QuantConnect. So let's have a look at what these numbers actually are. We have the stock ticker on the left-hand side, and then the Trump beta value here. So what this is saying is if these values are going to be between -1 and 1, if the value is 1, then the stock's price movement is perfectly correlated with Donald Trump's betting odds movement. Okay, so let's head over into our algorithm and look at getting the custom data into it. So as always, we're going to start off in the docs and try and find a nice template to begin with. So let's head over to importing custom data. Let's go down to the bottom, midway through, and we can see this weather class that we've got here. So let's copy this over. Okay, and let's also remember to drop in some imports for later. So we're going to do import math, import pandas as PD, and then from IO import string IO. So we'll have a look at what these are used for in a bit. Okay, so let's rename this class to Trump beta. Let's get rid of that. And this source here, we don't need that. We're going to use our own data set. So I'm going to include it as a global variable so we can access it from elsewhere in different classes. So here it is. Let's call it data URL, and let's go back down to here and make sure we've changed this source to data URL as well. Okay, so the way that the custom data works, as we've given it a CSV, that means that it's going to take in each line and evaluate it as it goes along. So this reader here, you can see it takes in itself, config, line, date, and whether the algorithm is live or not. So this is the line that's going to take in. So we know that the first line is actually going to be a line with the dates and the column names, and the column names are the stock tickers. So let's split the line up. So let's go here. We're going to create this list here called data, which is going to split up the line into all the different data points. And we know for the first line here, so this first line, this makes sure that this is the first line, there is no data on it. We are going to create a columns dictionary. And so this columns dictionary is going to have the keys as the column names, so the tickers, and the values are going to be the index number. And what this will allow us to do is later on when we're receiving lines of data which don't have the column names, which is just data, it'll allow us to find out which data point is for which by using the dictionary and the tickers. So let's go data I. So that's going to be the column name. And then we've got I there for I in range, length of the data list. Okay, and so the reason we set it as self.columns is so that it stays persistent even after this method has been run, as we only get to see these columns once on the first line. So let's change these variables here now. So let's call this Trump beta and make it a Trump beta class. And let's just copy and paste these along. And we don't need these two values as we're only going to have one value, which will be our Trump beta value. And let's make sure to return this. Great. So here we've got the Trump beta.symbol. So we're going to create this we're going to create a symbol taking the value from here, and it's going to be a security type of equity. And it's going to be the USA market. So you can see it takes this config, which we take as a parameter in, and this is going to give us the symbol of the security we're trying to add the data for, and the value just gives us the string representation of it. And so we are just going to create a symbol out of that and assign it to this. So in fact, let's just create a ticker variable to make it a bit easier. So let's go config.symbol.value. Let's put that there and replace that with ticker. Great, and so the time. So let's take this away, and this is where we're going to look at our data, and then we're going to use our self.columns, and we're going to feed it date. So remember, this self.columns is a dictionary with keys of the column names and values of the index position of that. So when we give it date, it's going to return 0, and therefore it's going to give us the first object in the data list, which is going to be the date. And we're going to add on a time delta of 1 day, and as you can see, this is to make sure that we get this data after the trading day, as we don't want any forward bias. Okay, and so for the value, we're going to do the same with what we did here, and I'm going to make sure to cast it, and we're going to cast this as a float. I'm going to go data, self.columns, and we're going to pass it through the ticker. So remember, same as before with date, this ticker corresponds to a index position which we have saved in self.columns. And what we're actually going to do here is we're going to get the value and check that it isn't nothing. So value equals data self.columns, and we're going to say if not value, then return none. So if there isn't actually a value, then we don't want to return this data point. And if there is, then we're just going to drop in our value. Okay, so we're also going to make one change here. So we're going to change it to end time. And so what this means is that it's now periodic data, and therefore it's not point in time data, which is what we want. Great, so that's completed our custom data class. And now let's have a look at implementing it in the actual algorithm itself. So let's go down the route of the algorithm framework. So let's start off with our universe selection. We're going to be using a manual selection, and we're just going to pass it through a list of symbols. So if we grab these two here, we're going to go copy, paste this in. Okay, and these symbols, let's create a function. Okay, we can get rid of this onData function here, and instead let's create a function called getSymbols. It's going to take self. Okay, so what we want to create here is we want to get the constituents of our data frame. So constituents equals pd.read_csv, and then we're going to create a string reader here. That's why we imported it up here with the self.download of our data URL. Okay, and then we're just going to take the columns, and we want to make sure that the date isn't in that, so we're going to say indexcol equals date. Awesome, and then let's return this symbol.create this list of symbols. So symbol.create, and then take the let's do C for each of the constituents. C for C in constituents. There we go. So this is going to return a list of symbols that we have got from our data frame. Great. So let's do that. Self.getSymbols, and there we go. That'll drop in there. Nice. So let's move on to the next section of the algorithm framework, which is the alpha creation. So let's go into here, and we're going to grab this alpha model class here. So we will use this as a template. So let's copy this and drop it in here and get rid of these comments. And so first let's have a look at onSecurities changed. So we're just going to do the standard and loop through all of the added securities and add the trump beta data for them, and then any removed securities which shouldn't occur here, but it's just good practice, we will remove the securities from our algorithm. So for added in changes.added securities, we are going to use algorithm.add data. You can see the algorithm instance is passed in here, algorithm.add data, and we want it to be the trump beta data for our stock, so added.symbol. Great, and let's just do the removed one. Okay, so for removed in changes.removed securities, and then just do algorithm.remove security and give it removed.symbol. Great, so that's our securities changed method done, and this will make sure that we receive the data for the stocks that we are adding to our universe. Okay, now let's have a look into this update method. So we're going to receive this data slice, which is going to contain the stock price data and then also our trump beta data. So we want to turn our trump beta data into a pandas series. So let's go trump beta equals pd.series, and we're going to create a dictionary. So we're going to have the key and then v.value for kv in slice.get, and here we're going to pass in the class of the data objects that we want. So we want our trump beta data objects, and so this is going to return a dictionary, and we want to grab the items so that we can get the key and then the value. Great, so now let's talk about how the strategy itself is going to work. So if you remember from the start, we're trying to reduce the political risk in our portfolio. And a way to do this is using the political beta and avoiding the stocks that have high correlation to Trump's betting odds. So this means that it reduces any unnecessary risk caused by Donald Trump sending a tweet, for example. So we want stocks with low Trump beta. So this beta, it doesn't matter whether it's negative or positive, we just want to avoid correlation to Donald Trump altogether. So that's why we're going to absolute it. So we're going to absolute our pandas series, our trump beta series, and we're going to sort the values. So this will sort them in ascending order. And then we're going to take the first, so let's create a new variable called threshold. And we're going to take the first, so let's just initialize our data frame, our alpha model here. So self, and we're going to create this threshold. So let's say we want to take the first quarter of the lowest correlated stocks. So the data that we currently have has the data for the S&P 500. So if we're going to take a quarter of that, we're going to take about 125 stocks and equally weight those. So self.threshold times the length of the data frame. So this is just in case, for example, 10 or 12 stocks don't necessarily have Trump beta values. We're just grabbing the length here. And so let's just make sure that's an integer by doing math.floor. There you go. So that's why we imported math up there. Okay, so this low Trump beta series is basically going to have a series with the index as the stock tickers and values as their Trump beta values for the 25% lowest correlated stocks to Trump's betting odds. So now we want to generate some insights from that. So we are going to say for security in low Trump beta dot keys, and we're going to create an insight. So let's call this insight equals insight.create, and let's just double check our documentation. So let's have a look at these. Here we go. So we just want a simple one with the stock ticker, how long the insight is going to last, and the direction. So let's take this. It's just going to be a price insight. So let's paste that in there. We're going to have the security. The time delta, let's call this 7 days. And the direction is going to be up. Okay, and now let's just append that on to our insights list. Great, and that's our alpha model done. Now we just need to move on to the next two parts of the algorithm framework, which is just going to be the portfolio construction and the execution model. So let's go back into the documentation, portfolio construction, and we're just going to want an equally weighted one. So let's just grab this and drop this in here. Okay, and so I've forgotten to add our alpha model. So let's rename this to Trump Beta Alpha Model. And have a look back at the alpha creation. Just double check. Yep, it's just add alpha. So self.add alpha and Trump Beta Alpha Model. Okay, and then for the execution model, so we've done portfolio construction. For the execution model, we're just going to have an immediate execution model. So we can just copy and paste this line in. Great, there we go. So we've got our universe selection, which is just all of the stocks that we have from our custom data, which is the S&P 500. And then we have our alpha model, which is going to select the 25% least correlated stocks with Trump's betting odds and create positive insights for this. So we're just going to create an equally weighted portfolio. And then a portfolio construction model, which is going to just equally weight these and immediately execute them. So now that we've got our algorithm all written up, let's see how it performs. So let's build it. Okay, so we're going to change our start date to, let's say, the 1st of June and see how it's performed in the second half of the year. Okay, so we can see that we're getting a few errors here, and it's saying must be string, not datetime.time delta. So this has come from our custom data here. I forgot to change this, as remember it's coming in as a string. I forgot to change this date into a datetime object. Let's just make sure that the Trump beta data that we're getting corresponds to securities that we actually have in our universe. So let's just go if algorithm.securities, so this is in our alpha model, dot contains key and security. So this makes sure that we're only producing insights for securities that we have price data for. Okay, so let's build this and backtest it. Okay, so our algorithm has finished running the backtest, and let's have a quick look at the performance. So we can see it's, let's just check that the algorithm itself is actually working, and you can see it is emitting about 125 insights each day, which is exactly what we wanted. But these performance numbers don't really mean much unless we compare it. So remember, this is the 25 least correlated stocks with Trump's betting odds. Now we want to compare this to the 25% most correlated stocks. So let's just flip this round. So we're taking the top 25% and let's run a backtest on this. And so while this backtest is running, let's just have a quick think about what we expect to see in this backtest. So remember, this backtest is adding in the political risk of Trump's betting odds. And so we should expect to see a higher annual variance, so more risk, and therefore, and possibly a higher drawdown as well. So let's let that backtest run and see how the numbers compare. Okay, so that backtest has finished, and we can see that it actually has a higher return and a higher probabilistic Sharpe ratio. But what we were interested in was looking at the absolute risk and the drawdowns. So let's see if, as expected, it has a higher annual variance and a higher drawdown. So annual variance 0.036, yep, that was higher than the 0.027, and we've got a drawdown of 11.7%, which is higher than the 9.5% drawdown we saw with the least correlated stocks. So implementing this strategy this way probably isn't the best way to implement it. The way you'd probably want to implement this is to instead construct your portfolio using market cap weighted, like the S&P 500 actually is, and possibly tilt different stocks' weights depending on how much political risk they have. So if stock X has a weighting of 2% in the portfolio, but it has a very high correlation to Trump's betting odds, potentially dial that down 0.5% down to 1.5%. So I hope you found this strategy interesting. I think it's important to look outside the traditional risks of specific risk and also have a look at how you can leverage alternative data in QuantConnect using a custom data class to reduce your political risk. If you'd like clarification on any of these points or have any questions, please do not hesitate to reach out. Both the team here at QuantConnect and the quant community, which is now over 100,000 strong, are valuable resources. And if you would like to put this idea or any other idea to the test, check out Quant League, a weekly rolling competition where the quants in the community put their alphas to the test for a $1,000 cash prize pool. See if you can win with your algo. Until next time, happy coding.